Alright, so we're starting chapter 8 today, and this is the last sort of big key concept from statistics. So we do confidence intervals chapter 7, and then chapter 8 is about tests for significance. They're also sometimes called hypothesis tests, but that's kind of the key idea. So we're going to do the same thing, we're going to do it about 4 different ways by the end of the semester. We're going to do 2 ways before the exam and probably 1 after the exam. And this will kind of give us a key idea kind of about what you do with the test. And I actually like the book has a really great example in the start of the section that talks about a manufacturer of emergency equipment asserts that respirators that make delivers pure air for 75 minutes on average. And the government regulatory agency is charged with testing those claims to make sure that the average time is not less than 75 minutes. So what the government would do, right, is collect a random sample of those respirators and compute the mean time that they deliver pure air and try to compare that to the mean asserted time of 75 minutes. So it's like this interesting idea, right, where you have an idea of what you think the population parameter is, right? You make an assumption about that, and then somebody tests or contradicts that or wants to know, well, maybe that's not the true situation, right? Maybe it's smaller than that, maybe it's bigger than that, maybe it's just not equal to that. And so then you can run a test and decide if there's statistical evidence, right, to say that maybe the original claim is false. So that's kind of what we're going for in these tests for significance. That's the idea of it, right? We're going to use a sample to try to decide if we can make a decision about this population idea. So again, sample to tell us something about the population. So there are 6 key steps, and I just kind of want to outline the steps today in the video, and then we're kind of going to go in depth with these steps in class. But I wanted to give you a general idea of how this test works, or these tests in general. The first thing you're always going to do is write down a null hypothesis and an alternative hypothesis. And so the idea here is that the null hypothesis is always this thing that's written as H naught. Naught is like a little null, it's like a symbol for that. And then HA is your alternative hypothesis. And the idea here, right, is that H0 or H naught is sort of what you assume to be true. Okay, so I think that the population, and this is always about the population, never about the sample, right? We don't need to assume something about a sample because we can always test the sample and know exactly what it is or what it isn't. So it's always about the population, and then HA is what you want to test. So do you want to test if it's different, greater, smaller, or whatever? And again, that's still about the population, and it's related to H naught. So I'm just going to, on the next page, go through a couple, like an example of what that might look like, and then I'll move on to the other steps. This is the big step that I wanted to focus on today and in this video, and we'll get through the other steps in class. So in the example that we just talked about, right, this manufacturing company wants to test this idea that the mean time that these respirators works is 75 minutes, or that's what they claim, right? And the government agency wanted to make sure that the average time is no less than 75 minutes. So they claim, right, that mu is 75, and that would be your null hypothesis. And your alternative hypothesis, the thing that you want to check, right, is that the mean time is not less than 75 minutes. So in other words, that mu is less than 75. So some things to notice about these hypotheses. First of all, this is always an equal sign here, right? That's the thing that you're assuming to be true. Some books might do that differently, but generally for all the hypothesis tests that I'm going to do, I really like for you to put an equal sign in the null hypothesis because that's the thing that you're assuming is true. And then this needs to be opposite of your null hypothesis. So that means you could have, right, mu less than 75, you could have mu greater than 75, or you could have mu not equal to 75. But you don't want to overlap, right? So, for example, you wouldn't want to have mu less than or equal to 75, because then these HA and H naught would have like an overlap, right? They would both be equal to 75, so whatever your test shows, either of those two things could be true, right, if it is actually equal to 75. So this, right, don't do the 70 less than or equal, right? You want to choose one of these three things. These are the only kind of conditions, right, you want to have for your test. Is either greater than, less than, or not equal. Those are the opposite of 75, right? Those are the only sort of situation. In our problem, in the context of our problem, it wanted to be less than. So that's what we chose, less than. So that's the first step, and that's the kind of key idea behind hypotheses, is to make sure you choose a good one. And then you want to choose them, and then the idea is now we're going to go through our whole test, and the key thing is the whole time, through the whole test, we're assuming that H naught is true. Okay, so you're going to assume the whole time that H naught is true, unless at the end you find statistical evidence that it's not. So that's the idea of the hypothesis test, is that we're going to take these two statements, we're going to assume the null is true, we're going to do all the statistics, and at the end, and only at the end, if we have statistical evidence, can we make a claim or change our mind that H naught is not the thing that we believe to be true. Alright, so I wanted to go through the other pieces of the hypothesis test, and then we'll kind of talk about those pieces more in class, but I wanted you to be aware of all 6 steps in the hypothesis test. So after you construct those hypotheses, your goal is going to be to decide on what kind of test you're going to run. So it depends, right, if you have means or proportions, right? So you need to decide on the means versus proportions and how many you have, like the number that you have. Sometimes, I don't know that we'll have time in this class, but you might have 2 means that you're going to compare or 2 proportions, and there's different tests for different things. And once you decide on that, you decide on what kind of test statistic you're going to calculate, and also what kind of distribution you're going to use, right? So is it Z? Is it T? We're going to talk about another one, about chi-squared, something we're going to talk about later. So there's different kinds of distributions, right? You got to use the right table and the right kind of distribution for whatever particular test you're running. And then once you decide on that, you need to check the conditions, right, to make sure that the test that you're actually going to run is going to work, right? And those conditions, again, are going to be related back to the central limit theorem, generally, for where most of these things come from. So once you decide what test you're going to do, make sure you're in the right test, do all the calculations to make sure you're in the right thing, check the conditions. The next thing you're going to do is calculate something known as a test statistic. And this will be a formula, and it's just a straight up formula that once you know what test you're in, you'll have the formula. You can get it off the formula sheet, plug in everything that you need, and you're going to calculate this particular test statistic that helps you decide, helps you compare sort of the null hypothesis, right, to what you're trying to compare it to. And so you're going to do this sort of comparison and calculate a test statistic. And those vary depending on the test that you run, and we'll look at examples in class of how to calculate them. So once you have a test statistic, the next thing you need is, and our book does this in a strange way, but they talk about something known as constructing the rejection region, which I'm not sure yet if, rejection region. I'm not sure if we're going to do it that way or if we're going to do it the other way, but that's what our book kind of focuses on at the beginning, is constructing a rejection region. Or what really generally happens in this step is calculating what's known as a p-value. So you'll need to do one of these 2 things, and I might talk in class a little bit about the difference between them and maybe why we're going to go a certain route. But this kind of, you take your test statistic and you compare it, right, to, like in a normal distribution, right? Maybe you're going to get a Z, which is a test statistic that's really high, right, like 4 or something, right? And we remember that the Z, the normal distribution, is centered at 0, and it has values mainly between -1 and 1 is the 68%, right, and then -2 to 2 is 95. So you got like a 4 as a test statistic, right? Then that's going to tell you something about the fact that possibly, right, this is a really rare occurrence, right? So you're really trying to take that test statistic and compare it to your distribution and decide, is this something that's really rare, or is this something that could happen, right? And if it could happen, then that's okay. But if it's something that's really rare, that might provide us statistical evidence to say that what we assume to be true is maybe not true. And that's kind of how the idea works. So we're going to do that in step 4, is kind of make a decision about a p-value or rejection region to decide if we would reject this or not. And then In step 5, we make a decision. So there we sort of calculate what the region is, or we calculate the p-value. But then in step 5, we kind of decide if we're going to reject the null hypothesis or fail to reject. And note, there's never an except. So don't use the word except. There's no accepting of any hypotheses. The only thing we're ever going to say is that we reject H naught, which means we have evidence in favor of HA, or we fail to reject H naught and continue to assume that it's true. Remember, in statistics, nothing's ever 100%, so we don't want to make any claims like it's 100% true that the null hypothesis is true, or 100% true that the alternative hypothesis is true. So we just got to be really careful about that. So these will be your sort of conclusions in step 5. It'll always be one of those two statements based on some things that we'll talk about how to make that decision. And there's one final step, and that is to write out your conclusion in the context of the problem. So you're going to get a fail to reject or a reject, and then I want to talk about what does that mean, right? So if we rejected our null hypothesis in the example that we talked about, that would mean that there's statistical evidence, right, that the mean is in fact less than 75 minutes for those respirators. If we failed to reject the null hypothesis, right, we might say something like there's not statistical evidence that the respirators, right, provide less than 75 minutes of airtime, so we will continue to assume that it is 75. So that's kind of what happens there in terms of context, right? So we make a decision to reject or not to reject in part 5, and then in part 6 we write that in context. So that's the big idea of a hypothesis test. It's 6 steps. We're going to create hypotheses. We're going to decide on the type of test. We're going to calculate the test statistic. We're going to decide on a rejection region or calculate a p-value. We're going to make a decision based on one of those two things, and then we're going to write that decision in the context of the problem.